Okay, so in this last problem, they actually give you the derivative. You got to be really careful with problems like this because sometimes people have the derivative and they take the derivative again. So in this case, all they're really asking you to do is set it equal to 0. So we set 0 is equal to 5 minus 4x times x plus 2 quantity squared. Okay, and then that gives us the critical points at x is equal to -2 and 5/4. So now if we make a sign graph here, we're going to be investigating, let's put it, we got -3, -2, -1, 0, 1, and 2. So our 5/4 is just beyond 1. So this is 5/4 here. And the other critical point was at -2. So let's go ahead and do a sign graph for that. So let's start first with the 5 minus 4x, which gives you a 0 here. To the right of you, got to be careful with this. To the right is going to be negative now, and to the left is going to be positive, which is usually switched. Then the second portion of this is going to be x plus 2 quantity squared. Now that square term makes everything positive. We just have a 0 value at that -2. So it's positive and then positive all the way across here. Okay, and so combining these together into the f prime, we have a -0 and then positives in between, 0 and a positive. So here we have the function, the original function is increasing, okay, in between -2 and 1, okay, it's going to be still increasing. And then between positive 5/4 and beyond, it's going to be decreasing. So putting all this information together, we can say there's a local maximum at x equals 5/4 because f prime of x changes sign from positive to negative. So just to review, today we talked about how the first derivative, the sign of it, either positive or negative, can help us if the original function is increasing or decreasing. And if it's equal to 0, okay, it implies it's constant. We talked about critical points that are potential maxes and mins. We focus solely on setting the derivative equal to 0. And then in later lectures, we'll talk about when f prime of c is undefined. And then finally, using the first derivative test, which is finding the critical points, finding where f prime changes, the first derivative changes sign, and talking about the local max or mins associated with it.